All right, let's start reviewing for our chapter test here. So first section we have uh, some old stuff, 41 degrees, 6 minutes, and 54 seconds in decimal form. Hopefully you remember how to do that. There'll be one or two questions like this on here where we convert back and forth. If we start with 41 degrees, 6 minutes, 54 seconds, if you remember correctly, 41 degrees stays the same. In order to convert 6 minutes back, you do 6 over 60, and then plus 54 over 3,600. Whenever you do that, you'll get a certain answer, and that's exactly what it will be. I don't know that we need to do it, but I'll do it anyways, just for you. Go to Desmos. Math tools. Yeah, I really thought that was going to work. So I would do 41 plus 6 divided by 60 plus 54 divided by 3,600. And that gives my answer there, 41.0999. You can round it off to 4 decimal places. Putting it in DMS form, you're going to remember the 10 stays the same. And I just do the decimal times 60. 0.5625 plus 60. I'm sorry, times 60. It gives you this number. And whatever is the decimal here, so it's 33 minutes now, and then you do 0.75 times 60 as well, and you'll get 45. And that's the seconds. So it's just 10 degrees. I don't remember what the other one was. 33 and 45. 33 minutes, 45 seconds. And that's it. If we move on to the next group of problems, which of the following statements about the angle theta is true? So if this is theta, then we know this is opposite, adjacent, and hypotenuse. Because this is the side that's the longest across from the 90-degree angle. Okay, sine is opposite over hypotenuse. So that's false, because opposite over hypotenuse would be 4 over 5. Tangent would be 3 over 5. That would be, remember, tangent, TOA, opposite over adjacent. The opposite side is 4, so that is also false. Sine is 4 over 3. Remember, sine is opposite over hypotenuse. It's got the opposite, but not the hypotenuse. That is false. Cosine theta, 5 over 4. Cosine is adjacent over hypotenuse. Which would be 3 over 5, so that's false, which hopefully that means that D is correct. Sine of theta is 4 over 5. Remember, sine is opposite over hypotenuse, so it is 4 over 5. That one is true. 4 through 9, use the right triangle in the figure to figure out each ratio. If I'm looking at sine of theta, again, I have adjacent, opposite. I need to find my hypotenuse. In order to do that, I use the Pythagorean theorem. 4 squared plus 7 squared equals c squared. 4 squared is 16, 7 squared is 49. 16 plus 49 gives me 65. Not a perfect root, so I'll leave it as a root of 65. C equals root 65. Since sine theta is opposite over hypotenuse, so that's 7 over root 65. Can't have the root on the bottom, so 7 root 65 over just 65. Cosine is adjacent over hypotenuse, so it's going to give us 4 over root 65, which is then equal to 4 root 65 over 65. Number 6, 10, that's opposite over adjacent, so 7 over 4. Now for these ones, remember cosecant is just the flip of the sine. So it would be root 65 over 7. Secant is the flip of the cosine, so root 65 over 4. And cotangent is the flip or reciprocal of the tangent. So that one turns into 4 over 7. All right, done with the first couple sections there. Solve triangle ABC. First one tells us A is 40 degrees and B is 10. So if I need to solve it, oof, that's a lot of work here. My hypotenuse is B. So I can use the sine to find my opposite side and my cosine to find this side. So I guess it's not that bad. Sine of 40 equals opposite over hypotenuse. So A equals 10 sine 40. Remember that these are degrees, so I need to keep it in degree mode. It is already in degree mode. 10 sine 40, 6.43. So that's A. I need to find C still, which means I can take the cosine of 40, because that'll give me my adjacent side. Let's go with C, because that's the adjacent side. So it's cosine 40 is C over 10. Multiply both sides by 10. I get 10 cosine of 40. And that's my answer, 7.66. Done. You can do some more of these. You don't have to do them all. Just make sure that you get a good feeling for how to do them. Number 15, from a point on level ground 145 feet from the base of a tower, the angle of elevation to the top of the tower is 57.3 degrees. Sometimes it's going to help you to draw a triangle. It looks really nice. What a really nice triangle. Okay, it's 145 foot from the base of the tower. This angle is 57.3 degrees. and we need to know how high the tower is. This looks like opposite over adjacent, so it's going to be TOA. Tan of 57.3 equals x over 45. Multiply both sides by 45. Do 45 tan 57.3. You're going to get 70.1. So 70.1, I believe it was feet. Yep. I don't know why I wrote degrees. It's clearly feet. All right, number 18. Here we have to start converting again. When we convert from radians to degrees, we have to do 9 pi over 5 times, and then going to degrees, it's 180 over pi. Pi's cancel out. 180 divided by 5 is 36. 36 times 9. 324. So it's 324 degrees. Going backwards, going from degrees to radians, do 36 degrees times pi over 180. In this case, it'll simplify. 36 goes into 180 5 times. So that's just pi over 5. Let's jump down to number 24. You should keep going and practicing on those in your notes, by the way. Find a number theta between 0 and 2 pi such that an angle of theta radians in standard position is coterminal with an angle of 23 pi, negative 23 pi over 3 radians in standard position. So we need to get our angle between 0 and 2 pi. So I start thinking of how I can relate 2 pi to this. Well, it has a denominator of 3. So if I have 2 pi over 3, I'm sorry, if I'm trying to get 2 pi in terms of a denominator of 3, in order to add this to 2 pi, I have to multiply both the top and bottom by 3, just like with normal fractions. If I was doing 2 minus 2/3, I have to get a common denominator. So in order to do that, I multiply both the top and bottom of this one by 3. It's going to give me 6 pi over 3. Now I could simplify that, which would obviously take me right back to 2 pi. It's not the goal here. If I subtract 23 pi over 3 from this, I'm still going to be left with negative 17 pi over 3, which is not between 0 and 2 pi. So I have to do this a couple more times. What I'm going to realize is I can multiply this by 3. That would give me 18 pi over 3. So basically I'm going around the circle 3 times. And now when I do that, 18 pi over 3 minus 17 pi over 3, I'm going to get my answer of just pi over 3. That is between 0 and 2 pi. There's a couple different ways to do that, but that's the way I'd like to do it. Through how many radians does the second hand of a clock move in 2 minutes and 40 seconds? So if it's going around 2 minutes, it's the second hand. That means it's gone around the full distance twice. So that would be 4 pi already. Then 40 seconds is 8/12 of a clock times 2 pi. Eight times 2 is 16. And then we can reduce that because it's over 12. So it'd be 4 pi. Weird. 4 pi plus, and then that's going to go all the way down to 4/3 pi. Now I can combine these two. I have to get a common denominator though. So I'm going to multiply the top by 3 to get 12. Multiply the bottom by 3. Twelve pi plus 4 pi gives me 16 pi over 3. So that's how far our second hand moved. Exercises 31 through 42 give the exact values. First, I'm going to need to simplify this because it has gone around and around multiple times. So basically, I need to subtract 2 pi from that because this is positive. 2 pi over, in order to get 2 pi in terms of 2 for our denominator, that would be 4 pi over 2. If I just subtract that, then I'm going to be left with 43 pi over 2, which means I'm going to need to do this multiple times. The other way I could do it is think of multiples of 4. Let's go even up to 4 times 10 is 40. So it's still smaller than this. 4 times 11 is 44. So that's how I'm going to start. 47 pi over 2 minus 44 pi over 2. And that just gives me 3 pi over 2. So that's my final answer. That's what this angle answer is anyways. Then if I look at my chart, what is the cosine of 3 pi over 2? That would be 0. Wow, went a whole long way for nothing. Let's look at number 13. I have negative 13 pi. If I add 12 pi to that, I would still have negative 1 pi. If I add 14 pi to that, I end up with sine of pi. And the sine of pi is just equal to 1. All right. What we're going to do is I'm going to stop this video. You need to practice with a lot more of these. And I'm going to go over more of it tomorrow.